Mastering data virtualization. Data virtualization unleashes query chaos and report generation nightmares. Which performance implications can we expect data virtualization to have on the execution of complex queries and the generation of comprehensive reports? Data virtualization can have both positive and negative performance implications on the execution of complex queries and the generation of comprehensive reports. On the positive side, data virtualization can improve performance in several ways. 1. Reduced data movement. Data virtualization eliminates the need to replicate or duplicate data, reducing the amount of data that needs to be moved across the network. This reduces the network latency and improves the overall performance of complex queries. 2. Optimized query processing. Data virtualization allows for optimized query processing, which can lead to improved performance. The data virtualization layer can analyze the query, identify the most efficient processing path, and optimize the execution plan. 3. Faster data access. Data virtualization provides a single, unified view of all data sources, making it easier to access and retrieve data. This can reduce the time it takes to execute complex queries and generate comprehensive reports. 4. Reduced CPU utilization. By offloading processing from the underlying data sources, data virtualization can reduce CPU utilization, freeing up resources for other tasks and improving overall system performance. However, data virtualization can also introduce some performance implications. 1. Additional latency. Data virtualization introduces an additional layer of abstraction between the application and the data sources, which can introduce latency. This can affect the performance of complex queries and report generation. 2. Increased complexity. Data virtualization can add complexity to the system, which can lead to performance issues if not properly managed. The virtualization layer can introduce additional processing overhead, slowing down query execution. 3. Data source bottlenecks. Data virtualization can expose bottlenecks in the underlying data sources, which can affect performance. If the data sources are slow or underpowered, the data virtualization layer can do little to improve performance. 4. Caching and refresh. Data virtualization often relies on caching and refresh mechanisms to improve performance. However, if not properly configured, these mechanisms can introduce additional latency and affect performance. To mitigate these performance implications, it's essential to 1. Optimize data virtualization configuration. Properly configure the data virtualization layer to optimize performance. This includes setting up efficient caching and refresh mechanisms, optimizing query processing, and tuning the system for optimal performance. 2. Monitor performance. Continuously monitor performance and identify bottlenecks in the system. This allows for proactive optimization and improvement of the data virtualization layer. 3. Choose the right data virtualization tool. Select a data virtualization tool that is optimized for performance and can handle complex queries and large data sets. 4. Plan for scalability. Plan for scalability and ensure that the data virtualization layer can handle increasing data volumes and query complexity. By understanding the performance implications of data virtualization and taking steps to mitigate them, organizations can ensure that their data virtualization layer provides improved performance, scalability, and reliability for complex queries and comprehensive reports.